Most organizations think their Azure problems are cost, network, or VM configuration. They are not. Your failures start in identity because identity is Azure's control plane. And when conditional access fails during an MFA outage, responders discover the break glass path wasn't protected. It was hidden from observation. We didn't design this wrong. We stopped designing it, and the system kept accepting every exception we gave it. Today, I'll show why identity debt accumulates by default, how it spreads through hybrid sync, conditional access sprawl, workload identities, and B2B guests, and how to measure it. If you can't inventory it, you don't control it. If you can't measure it, you can't pay it down. Later, I'll show you how to see this drift in your own logs, without a lab. The foundational misunderstanding, identity as control plane. Most teams treat Microsoft Entra ID like a login service. They are wrong. Architecturally, it is something else, a distributed decision engine that compiles identity signals into authorization across Azure, M365, and every federated app you've consented. That distinction matters. Every sign-in, every token refresh, every app consent routes through this engine. Your policy isn't a static document. It's an executable program that evaluates users, devices, risk, protocol, and exclusions, then emits allow, deny, or prompt. The more you patch exceptions onto intent, the more your outputs become probabilistic. Deterministic policy becomes conditional chaos. Define this once so it sticks. Entropy generator. An identity control that increases state complexity faster than it reduces risk when exceptions are added. Conditional access without lifecycle ownership is an entropy generator. Hybrid sync without translation rules is an entropy generator. Workload identities without ownership are entropy generators. Guests without lifecycle are entropy generators. These pathways accumulate. Here is the debt pattern we'll reference throughout. Intent, translation, exception, orphan, persistence. Intent, least privilege, MFA, no legacy protocols. Translation, will sync AD, add baseline CA onboard apps. Exception, temporarily exclude this group, this app, this vendor. Orphan, owner left, control still exists, no telemetry ties it to risk. Persistence, temporary became permanent, blast radius increased. The authorization graph mutates at every exception. Groups nest, roles accrue, service principals acquire directory, read-write. All just for now. Guests are excluded until the migration ends. Your control plane remembers everything you told it, long after you forgot why. Over time, policies drift away from intent. That's identity debt. Why networks and endpoints can't compensate? They don't see the authorization compiler. Firewalls don't evaluate Entra's device filters. EDR doesn't understand CA's exclude break glass clause. You can harden hosts and segment subnets, but the decision to issue a token, and what that token can do, lives above them. When identity is the control plane, everything below it becomes best effort containment. Let me ground this in system behavior. Synchronization compiles on-prem group semantics into a flat tenant with roles, scopes, and admin units. OU intent is lost in translation. If synced admins arrive with broad rights, Azure inherits over-permissioned identities deterministically. Conditional access compiles if-then logic at runtime. It's an execution engine, not governance. Every exclusion is a branch that bypasses your policy pipeline. Branches multiply. Coverage fragments. Report-only purgatory feels safe until an outage proves otherwise. Tokens are short-lived, but refresh is long-lived. If an identity's standing privilege is wrong, short-lived tokens just refresh the wrong decision every hour. Least privilege must exist before the token is minted, not after it's used. Workload identities never see MFA. That's by design. They either have secrets, certificates, or federated credentials. If they're overscoped, you won't get a helpful prompt. You'll get silent drift in your tenant. Guests don't share your assumptions. Cross-tenant trust settings, access reviews, and group nesting rules either encode the trust boundary or dissolve it. Temporary collaboration without lifecycle becomes privileged persistence. Now the uncomfortable truth. Your identity program likely lacks lifecycle. There is no practice path to remove an exception, rotate a secret, decommission a vendor, or retire a policy. Therefore, the exceptions win. Governance requires ownership, review, and expiry. The execution engine only enforces whatever remains. Measurement must arrive early. If you can't inventory exclusions, legacy auth attempts, non-expiring secrets, broad graph grants, privileged guests, and synced admins, you're guessing. Start thinking in queries, not dashboards. Sign-in logs filtered for excluded from policy. KQL for legacy protocol usage over time. Graph queries for service principals with directory. And no owner. Access review completion rates for privileged groups and guests. Identity debt is not theoretical, it's observable. The logs tell you where the control plane is already diverging from intent. Once you see that divergence, the case studies make sense. And once you accept identity as the control plane, you'll stop expecting networks to fix authorization. Case study context 1, hybrid identity debt propagation. Hybrid is where Azure inherits dead deterministically. Active Directory synchronizes objects. It does not synchronize intent. That distinction matters because the minute you flip on synchronization, Entra compiles your on-prem assumptions into a flat tenant with roles, scopes, and admin units. OU hierarchy, GPO scoping, and delegated OU rights don't exist in Entra. They collapse into groups, role assignments, and if you build them, administrative units. The translation throws away structure you relied on for least privilege. Here's what the system actually does. It reads users and groups, applies attribute flows, projects identities into the tenant, and links them to your authorization graph. If a domain admin is also an Exchange admin and sits in 3 legacy IT all access groups, synchronization doesn't challenge that design. It preserves it. Azure doesn't ask why. It accepts the input and emits tokens accordingly. Dead signals show up early if you know where to look. Start with the obvious one, synced global administrators. If any global admin accounts are on-prem and synchronized, Azure now trusts your domain controller health to guard the tenant's most powerful role. That's not resilience, that is coupling. If those accounts share passwords, if those admins sign in from unmanaged devices, Entra will honor that path because synchronization blessed the identity. You just extended your blast radius across planes. Second signal, legacy protocol residues. You said block legacy authentication, but Exchange Online still honors IMAP or POPE for certain mailboxes because a temporary exception sits in the tenant. Password spray hits legacy endpoints. The CA policy that would have blocked it never evaluates because legacy auth doesn't support modern claims. Hybrid made it easy to believe we blocked it on the firewall. The authorization compiler never checked your firewall. Third signal, flat group structures. On-prem, you used OUs to reflect departments, regions, and admin boundaries. In Entra, there is no OU tree. If you synchronize raw groups with vague names and broad membership, you manufacture universal keys. Those groups become assignment scaffolding for app roles in Azure RBAC. They drift from HR London to HR to everyone who asked. And nobody notices because membership still syncs cleanly. Clean replication of bad semantics is still bad. Now the failure modes. Failure mode 1, shared admins. A help desk service account with domain admin privileges created to work around a legacy tool is synchronized into Entra, added to a group that has global reader for convenience, then later elevated to privileged role administrator during a migration. Nobody rotated the password, nobody added PM. That identity now escalates in the cloud with the same shared secret that half the team knows. Failure mode 2, NTLM and IMAP ghosts. Your password hash sync works, your pass-through agent is healthy, and federation is gone. But POP and IMAP are still enabled for a handful of mailboxes because a third-party archiver needed it for a week. 6 months later, the same mailbox becomes the foothold for a password spray. Conditional access never saw the traffic. Your logs show legacy auth succeeded from an unexpected ASN, but your policy engine wasn't called. Failure mode 3, OU semantics lost. You delegated OU scoped admin rights to a regional IT team on-prem. In Entra, you never created admin units. The same team asks for app admin to manage a local SaaS. You grant application administrator tenant-wide. Intent was regional scope, translation yielded tenant scope. That is not drift. That is design omission. Hybrid also breaks privilege boundaries during incidents. During a domain controller outage, password hash sync stays good long enough to keep authenticating cloud users. That feels like resilience. Then your responders realize their on-prem admin identities were also their cloud admin identities. They can't isolate one plane without sacrificing the other. Privilege accretion survived sync, and now outage handling must account for 2 control planes with 1 set of credentials. Here's the uncomfortable truth surfacing again. Lift and sync erodes least privilege before day 1. Not because synchronization is flawed, but because translation from OU-based governance to role-based cloud scope was never designed. You synchronized identities. You did not synchronize boundaries. If you're an identity architect, this is where your design leaked. You assumed OU semantics would survive a platform that doesn't have OUs. So what should you observe today? Entra users flagged on-premises synced who hold global administrator, privileged role administrator, or application administrator. Sign-in logs showing client app legacy authentication events tied to synchronized users. Groups with generic names used in Azure RBAC assignments at subscription or management group scope, whose owners are synchronized and unaccountable. No admin units or admin units without role assignments, meaning your regional delegations are fiction. Once you see those, the fix pattern becomes obvious in the next section. Break the inheritance, localize power, and separate cloud admin lifecycle from on-prem. Because until you sever those couplings, Azure will continue to faithfully compile your oldest assumptions into today's authorization decisions. Hybrid identity, break the inheritance, localize power. The thing most people miss is simple. The cloud will faithfully preserve whatever privilege accretion you hand it. It does not negotiate. If you want least privilege, you have to assert it here at the control plane with constructs the engine actually understands. Why this matters. When admin identities and permissions flow from AD to Entra without redesign, You are not integrating. You are extending blast radius. Every incident, every exception, every shared account now spans two planes. The reason this works is deterministic. Synchronization copies objects, authorization compiles them. If you remember nothing else, remember this. Break the inheritance before you attempt control. What to change? You need 3 moves that reassert intent in cloud-native terms. Cloud-only admin identities that never synchronize. Role scope that matches reality enforced via admin units. Just-in-time access, so privilege exists only when needed. Let me show you exactly how to anchor each one. First, cloud-only admin roles. Create administrator accounts that live only in Entra. No on-prem UPN, no synchronization object, and no password sync dependency. Assign them administrative roles through privileged identity management so they are eligible, not standing. The reason this works is you've removed the coupling to domain controller, health, and local machine posture. Your cloud admin credential can be fenced with phishing-resistant strengths and device requirements the on-prem account can't satisfy. Once you nail that, everything else clicks. Passwords for operational identities stop being your incident workaround, and break glass becomes a tested path, not an assumption. Second, localize power with administrative units. OU semantics don't translate, therefore you must reintroduce scope deliberately. Build admin units aligned to the natural seams of your organization, region, subsidiary, or function, and place the users and groups that truly belong to that scope inside. Then delegate only the roles that team needs against that admin unit, not the tenant. Help desk, user administrator, groups administrator, limited to that boundary. The game changer nobody talks about is what you don't add. Never add the group itself if your intent is to manage the people. Add the users. Otherwise, you've created an elevation path by membership manipulation. That distinction matters. Third, enforce just-in-time with PIM. Standing privilege is not resilience, it's security debt. Make every privileged role eligible. Require strong authentication at activation. Add an authentication context if you want a compliant device or a known location for elevation. Set maximum durations that reflect real work, not 8-hour defaults. The reason this works is you're forcing the authorization compiler to reevaluate risk and controls at the moment privilege materializes, not after the fact. And yes, document approvals. If nobody approves anything, then time is your only guardrail. Treat durations as blast radius windows. Now here's where most people mess up. They block synchronized global admins, but leave synchronized application administrators, cloud app security administrators, or exchange administrators intact, rationalizing it's not global, it is not. But those roles compose attack paths when combined with app ownership and consent flows. Remove synchronization for any identity that holds tenant-level roles. If you must delegate to synchronized users for business operations, keep those roles scoped to admin units or application objects, and keep the path to tenant-wide rights cloud only. Evidence you can pull today to verify progress. Entra users list filtered to on-prem sync enabled equals true intersecting with directory role assignments. That surface should be empty for tenant-wide privileged roles. Role assignment inventory where scope equals what tenant root. Every principle here should be cloud-only, PIM eligible, and bound to phishing-resistant strengths, admin units with role assignments. If you have admin units but 0 assignments, you've built boxes with no locks. You haven't localized power. You've only drawn a map. Common mistakes to avoid. Treating 80 groups as truth for cloud roles. Group membership in a synced group is not a control boundary in Entra. It's an entropy generator. If you need a group to receive a privileged role, make it a cloud-only group, flag to accept directory roles, and keep membership assigned, not dynamic. Ignoring privileged access workstations for cloud auth. If your admins can elevate from unmanaged devices, your compliant device story is a slogan. Tie PIM activation to an authentication context that enforces a compliant, registered device or a hardware-backed passkey, relying on pass-through or federation to keep auth on-prem. Federation does not change where authorization happens. Conditional access still compiles in Entra. You've added fragility without gaining control. Quick win you can achieve today. Isolate break glass from synchronization. Create 2 cloud-only emergency access accounts with long vaulted passwords and no conditional access enforcement other than location allow listing. Then verify 2 things. They sign in and their sign-ins show up in your logs. If you can't see them, you can't trust them. Then enumerate synchronized admins, remove tenant-wide roles from any synced principal, and replace those paths with PIM-eligible cloud-only accounts scoped through admin units. That severing of inheritance is the pivot. Once you do it, your hybrid story stops being a liability and starts being a choice. Case study context 2, conditional access policy sprawl. Once you sever hybrid inheritance, the next entropy generator is waiting. Conditional access. It starts elegant, a few clear policies. Then the complaints arrive, the outages happen, and the execution engine gets paved over with exceptions. 2 years in, CA becomes identity dead central. The symptom pattern is consistent, policy per problem, exclusions per complaint. Someone can't access a legacy app, so you create an app-specific policy with a bypass. An executive gets prompted too often, so you exclude a group. A vendor needs temporary access, so you carve out a location allow list. None of these are governance. They are branches in code you no longer review. Branches multiply. Dead signals are loud if you listen. Pause here. This is the mistake most teams don't see. The first is the comfort phrase, exclude break glass. You meant to protect emergency access. Instead, you hid it from evaluation and from observation. If a sign-in never meets a policy, it never emits the telemetry tied to that policy. Break glass wasn't protected, it was invisible. That distinction matters. Second signal, app-specific bypasses with no owner. Look for policies that target one application and exclude one or two groups temporarily. If the policy object has no business owner, no expiry, and no last reviewed note, you're running unaudited code in production. Ownership is governance. Everything else is drift. Third signal, overlapping controls. You require MFA in one policy for all cloud apps. You require phishing-resistant strengths for privileged roles. You block legacy protocols in a third, but then you exclude trusted locations on the first, exclude service accounts on the second, and carve out IMAP on the third. The evaluation pipeline can produce contradictory results across paths. The outcome is probabilistic. Access depends on which branch short-circuits first. If you remember nothing else from this section, remember this. Conditional access debt hides in the paths where policy never runs. If you don't fix those branches, your next outage will be negotiated with exceptions you can't see. Here's the near miss most teams don't forget. An MFA provider outage overlaps with your MFA for all users policy. Your responders try to use break glass. It works, technically. But because the account and path were excluded from policy, the sign-in doesn't appear where the team expects. No alert, no visibility. The responders assume they're still blocked. Minutes turn to hours. The incident drags because the escape hatch was never validated under failure and the telemetry was never wired to observation. If you're a security leader, this is the metric you should demand. How many privileged sign-ins show conditional access not applied and why? Root cause every time, treating conditional access like governance. It is not. It's an execution engine that compiles if-then rules at sign-in. It will enforce perfectly, even when what remains is wrong. Governance implies lifecycle, ownership, review, expiry, measurement. CA does none of that for you. Report-only mode feels like safety, but it's often purgatory. Policies sit there indefinitely because turning them on is scary. Meanwhile, temporary exceptions remain the only enforced code. Before we continue, you need to understand the evaluation flow at a glance. The engine loads applicable policies based on user, group, role, app, and conditions. It processes blocks first if any policy says block, access ends. Then it applies grant controls, combining requirements with AND logic unless you explicitly configure OR. Exclusions remove objects from the policy scope before evaluation. That's the pathway where debt hides. You bypass the compiler altogether. Let's ground this before moving on. If a sign-in is excluded, no amount of monitoring will ever show you the control that didn't run. Evidence you can pull without clicking through every policy. Sign-in logs filtered for conditional access not applied with a reason of user excluded or application excluded. Those are the blind paths. If they appear for privileged roles or sensitive apps, you have unaudited code running. A KQL trend of legacy protocol attempts alongside CA results. If legacy traffic shows up and CA is not applied, you're relying on a block that never evaluates. That's not control, that's hope. A policy inventory showing count, targets, and exclusions. If your policy count grows linearly, while your coverage of all cloud apps shrinks, you're trading simplicity for fragmentation. Now the behavioral mistake. Trusted locations are treated as a get-out-of-prompts zone. The network feels safe, but conditional access has no context of whether that IP range actually binds to managed devices or whether the traffic is proxied. You just taught the compiler to trust a CIDR more than a device posture. That choice outlives the justification. Another recurring trap. Service accounts excluded from policies. There is no such identity class in Entra for CA. You created a group, you labeled it, you excluded it. You now have human principles hiding in a category the engine cannot distinguish from automation. Workload identities don't even evaluate CA. Humans do. Your exclusion is an entropy generator misapplied to people. And then there's report-only limbo. Teams stage 10 policies, wait for the perfect moment to turn them on, and leave them inert for quarters. Meanwhile, incident reviews keep pointing at the same gaps. If a policy sits in report-only for more than a sprint, it isn't staging. It is indecision encoded. What should you recognize in your tenant today? Policies that target all cloud apps but exclude one or more executive groups, emergency access, or entire locations. App-targeted policies with no metadata on owner, reason, or expiry. Conflicting grant controls across paths. MFA required here, phishing resistant only there, device compliance waived somewhere else. Not applied sign-ins for privileged roles. If you see those, you've confirmed sprawl. The fix is not more policies, it's fewer branches, stronger strengths for high-value roles, and a hard stop on exclusions without an owner and a clock. The execution engine will enforce whatever remains. Make sure what remains reflects intent. Conditional access as authorization compiler, baseline, strengths, and blocks. This is the uncomfortable truth. Conditional access is an authorization compiler. It takes context at runtime, who you are, what you're touching, where you're coming from, the device posture, and compiles it into a decision. Baseline first, then strengths, then blocks. Keep the surface small, keep the branches obvious. Everything else is entropy. Why start with a baseline? Because the compiler needs a predictable core. If you try to reason about 10 overlapping policies, you won't. So set 3 and mean them. Baseline 1, block legacy authentication. Not reduced, not softened, not except for, block it. Legacy protocols don't emit the signals the compiler needs. They bypass the policy pipeline by definition. If you leave any door open, your logs become a weather report. Interesting, not controlling. Baseline 2, MFA for all users. Yes, all. The compiler should always have a second factor to resolve risk when signals are ambiguous. Use it as a floor, not a ceiling. You are not promising perfect assurance. You are avoiding single-factor chaos. Baseline 3, phishing-resistant strengths for admins and critical apps. This is where the baseline becomes opinionated. A privilege token minted on the back of a push notification is a time bomb. Strengths, FIDO2, certificate-based, passkeys, bind the assertion to a device or a key. That distinction matters. The thing most people miss is that strengths are not just harder MFA. They collapse entire classes of failure. No prompt bombing, no shared OTPs, no SIM swap recovery. When you require a phishing-resistant strength, the compiler can stop asking the network to be your identity perimeter. That is the shift. Now, how to express that cleanly without building a labyrinth? Think in 3 policies, not 13. Policy A, block legacy authentication. Target all users, all cloud apps, client apps, condition set to legacy protocols. No exclusions. You do not need to be clever. You need to be complete. Policy B, require MFA for all cloud apps. Target all users, all cloud apps. Grant controls require multi-factor authentication. Minimal exclusions for break glass only and time-boxed, owned, and logged. If an exception does not have an owner and an expiry, it is not an exception. It's an orphan. Policy C, require phishing-resistant authentication strengths for privileged roles and high-value apps. Target directory roles and the specific enterprise apps that move money, modify policy, or administer identity. Grant controls require authentication strength phishing-resistant. Consider also an authentication context for PM activation, so elevation inherits the same bar. This next part separates beginners from pros. Do not stack overlapping policy scopes that silently weaken the strongest requirement. The compiler evaluates blocks first, then it combines grant requirements with AND logic inside a policy, but across policies, the effective result is the union of requirements applied to the request's path. If a weaker policy excludes the object, it vanishes. That's why branches matter more than counts. Once you nail the baseline, everything else clicks. You isolate high-value paths with strengths. You block the unobservable legacy flows. You stop treating MFA as a universal solvent and start using it as table stakes. Now, the blocks. There are only 2 that deserve to exist. Block 1, legacy authentication. We already covered it. It's non-negotiable. Block 2, known bad risk. If you have Entra ID protection P2, high user risk and high sign-in risk are blocks, not prompts. If the engine believes the credential is owned by someone else, you don't negotiate. You cut power. Everything else, use grant controls, not blocks. You want the compiler to shape the assurance to the action, not strand users on the wrong side of a line because they moved from Wi-Fi to LTE. Evidence that you can pull to prove this is working is straightforward. Policy evaluation flow, where legacy protocol requests show blocked by policy legacy authentication with 0 not applied for legacy client apps. If you see not applied, you don't have control. You have a story. Authentication methods, registration, showing coverage of phishing-resistant credentials for every principal in a privileged role. If a role has members with only passwords and OTPs, you've labeled risk admin. Sign-in logs filtered to privileged roles with authentication requirement, phishing-resistant. If that field isn't present, you required nothing. You hoped. Here's the shortcut nobody teaches. Reduce your policy count before you raise your policy bar. Every policy you don't need is a branch you won't debug at 2 a.m. Inventory exclusions with owners. Delete or timebox anything without one. Move trusted location logic to authentication context tied to device compliance instead of CIDRs. Treat service accounts as what they are, humans or workloads. Humans evaluate CA. Workloads do not. Exclude neither by label. Common mistakes to avoid. Requiring MFA for admins but not requiring strengths. You just made prompt spam your last line of defense. Using report only as a parking lot. If a policy can't go to on within a sprint, it belongs in backlog refinement, not production. Carving permanent location-based bypasses. The compiler can't see the difference between your office and an IP-spoofed range. Device posture is real. IP space is theater. Quick win. Cut to 3 policies. Require strengths for anyone who can change authorization or compute, and run a not applied sign-in report for privileged roles. If the list is non-empty, you have blind paths. Reduce them before you add anything else. The authorization compiler will enforce what remains. Make sure it's worth enforcing. Case study context 3, service principals and workload identities. This is where the control plane goes quiet, no prompts, no pop-ups, no human in the loop. Service principals and managed identities are production identities that never see MFA and rarely see owners. When they drift silently. Why this matters? The system treats a workload the same way it treats a person in one critical regard. It mints tokens that can administer your tenant. But unlike people, workloads don't get challenged. If the scope is wrong, the compiler says yes at machine speed. The dead signals are consistent. Long-lived client secrets. Broad graph scopes like directory. Read-write all for the pipeline. Enterprise applications with no owner, certificates that expire in 2034, sign-in logs that never show up because nothing interactive happens. That is not resilience, that is unobserved authority. Here's the pattern you've already seen, applied to automation. Intent, translation, exception, orphan, persistence. If you remember nothing else from the workload identity section, remember this. Every temporary elevation for a pipeline becomes a permanent attack path unless someone owns its lifecycle. Intent. Let the pipeline create app registrations and assign roles. Translation, grant directory, read-write. All to this service principal, it's easier. Exception, skip rotation until after the release, extend the secret. Orphan, the dev who created it left. The app still works, nobody owns it. Persistence, it ships features, nobody questions the scope. Now the incident pattern most teams deny until the post-mortem. A CI/CD variable leaks in a console log, a wiki page, or an artifact. That variable is a client secret for a service principal with graph write permission. There is no owner to call. There is no rotation policy to enforce. The attacker doesn't need to guess a password. They call graph and modify app permissions, add credentials to an existing enterprise app, or consent a high-risk API on behalf of your tenant. Nothing prompts, nothing alerts, unless you instrumented the right logs. Root cause, treating a workload identity like a convenience instead of a principal. If a principal can write your directory, it is a shadow admin. Before we continue, you need to draw the boundary in your head. Service principal, managed identity, and federated workload. The service principal is an app identity you create and credential with a secret or certificate. A managed identity is a special service principal Azure creates and rotates for a resource. A federated credential lets an external system like GitHub Actions exchange its token for yours without storing secrets. Each solves a different coupling problem. None solves over permission on its own. That shows up first where you gave yourself speed. Secrets over certificates. Certificates over federation. Owner set to the developer who created it. Expiry set to never because rotation would break the weekend release. That's not an accident. That is design omission disguised as velocity. Evidence you can pull without a clicking class. A graph query for enterprise applications with app role assignments matching directory. And no owners, that is your high-risk list. If an app can write directory objects and nobody owns it, you have an attack path with no steward. Credential inventory for application registrations showing key credentials and password credentials with expiry dates beyond 1 year. Long duration correlates with forgotten rotation paths. Sign-in logs filtered by service principal sign-ins with unusual consent or app role assignment activity. Yes, these exist. If you're not looking, you won't see drift. Now the common failure modes. Failure 1, one key to rule them all. A single service principal in a build system holds subscription contributor, key vault, secrets officer, and graph write. The pipeline needs one of those at a time. The principal has all of them all the time. Compromise equals tenant modification plus secrets exfiltration plus infrastructure control. That is not least privilege. That is consolidation of blast radius. Failure 2, forever secret. A client secret created during an outage to get prod back never rotates. 10 months later, someone screenshots an environment variables page. The screenshot lands in a ticket. The secret remains valid. The attacker doesn't need to fish. They authenticate as you. Failure 3, no owner, no review. An external SaaS integration created via admin consent has owner none. It keeps working for years. The vendor changes scopes. Nobody gets notified. Your tenant silently accepts newly requested permissions because the app already existed. Governance failed at the first step, ownership. The uncomfortable truth, conditional access won't save you here. Workloads do not evaluate CA. You cannot fix scope at sign-in. You can only fix scope at definition. What should you recognize today? Enterprise apps with broad graph permissions and no owners. Application credentials with long expirations or end date time missing. Build systems using service principals with tenant-level scopes when a managed identity scoped to a resource would suffice. Human accounts labeled service excluded from CA because a pipeline needed a token. Humans evaluate CA, workloads don't. This is a category error turned into an exception. Once you see those, the next move becomes obvious. Prefer managed identities in Azure to eliminate secret handling where possible. Use certificates over client secrets when you must create app registrations, federate external CI/CD to avoid storing credentials, and most importantly, cut scopes to the minimum operation needed. Treat workload identities as production identities with lifecycle, ownership, and rotation, because the compiler will keep saying yes until you change what it's allowed to say yes to. Workload identities from shadow admin to governed principal. The foundational mistake is thinking of a service principal as a convenience. It isn't. It is a principal. If it can write directory objects, assign app roles, or mint tokens that manipulate subscriptions, it is a shadow admin. The system doesn't care that it runs at 2 a.m. and never prompts. Authority without observation is still authority. Why this matters. Workload identities outnumber humans, and the compiler never asks them for MFA. The consequences of doing this wrong are predictable. Silent privilege, durable access, and escalation paths with no human in the loop. The benefit of getting it right is equally predictable. Scoped authority, visible ownership, and bounded blast radius. That distinction matters because conditional access can't save you here. Your only control is definition and lifecycle. What to do instead is not complex, but it is non-negotiable. First, prefer managed identities in Azure wherever possible. A managed identity is still a service principal, but the platform owns the credential and rotates it. You remove the class of failure called forever secret. More importantly, you reduce coupling. The identity exists in the boundary of the resource, so its scope tends to match reality. A function gets function-level permission to a storage account, not tenant-level graph write for convenience. Second, when you must create app registrations, choose certificates over client secrets. A certificate with a sane expiry and storage in Key Vault is not perfect, but it collapses the easiest leak path, screenshots of environment variables, and plain text config files. Pair that with short validity windows and a rotation schedule you actually practice. If you cannot rotate on demand, you do not control the principal. You are borrowing time from your future incident. Third, right-size scopes. The reason this clicks is straightforward. Workload identities never get challenged at runtime. If you grant directory, read-write all, the compiler will say yes every time. Move to the minimum graph permission that encodes the operation. Use app roles on your APIs instead of broad graph grants where possible. At the Azure control plane, stop handing contributor at subscription when a resource group role or a single resource data action would suffice. Scope is your only guardrail. Fourth, assign owners and enforce lifecycle. Owner, none is governance dead. Every enterprise app and app registration must have at least one accountable owner who is not a departed developer or a group with unknown membership. Owners approve permission changes, own rotation, and get paged when the principal trips an alert. Without an owner, you will always choose product velocity over control. Not because you're reckless, but because nobody is responsible. Let me show you exactly how to make this practical without turning this into a clicking class. Inventory the threat surface with 3 queries and 1 report. Graph. Enterprise apps with app role assignments matching directory and owners count equals 0. That is your shadow admin without a steward list. Work that queue first. Graph. Application registrations where password credentials end date time is null or greater than 365 days. Those are your forever secrets. Set rotation deadlines and replace secrets with certificates or federated credentials. Graph. Service principals granted roles at subscription or management group scope. Map each to a workload. If the assignment doesn't line up with a resource that needs it, you found consolidated blast radius. Sign-in logs, service principal sign-ins with consent or app role assignment activity. Nothing interactive should be consenting to anything. If you see it, that's drift. Then constraint creation. This is the game changer nobody talks about. Most drift starts at birth. Guardrails at creation are cheaper than cleanups later. Disallow user consent for apps. Require admin consent workflow with ownership as a prerequisite. Require a tag or application ID in the display name that maps to a system of record. If you can't trace a principal to a service, you won't decommission it. Enforce conditional access for admin consent portals with phishing-resistant strengths for the humans who approve. The workload doesn't evaluate CA, but your approver does. Now the migration choices. If a pipeline runs in Azure, switch to a user-assigned managed identity and scope it to the resource it touches. If it runs outside Azure, federate its identity instead of storing secrets. GitHub Actions, for example, can exchange its token for yours on every run. Reserve app registrations with certificates for systems that neither run in Azure nor support federation. This sequence eliminates entire classes of credential handling. Common mistakes to avoid. Consolidating roles for convenience on one principal. That is an entropy generator with root on 3 planes. Split duties, 1 identity per function. Relying on service human accounts to acquire tokens. Humans evaluate CA, workloads don't. Your exclusion to make the pipeline work just created a persistent blind path for people. Treating Key Vault as governance. Storing a secret safely is not the same as scoping the principal correctly. Vaulted over permission is still over permission. Evidence of improvement looks like this. The high-risk graph list shrinks to 0 or to a small justified set with owners. Credential lifetimes collapse to 90 days or certificates with automated rotation. Service principal sign-in logs stabilized to predictable patterns tied to change windows, not ad hoc admin activity. Role assignments move down from subscription to resource group or resource level, and from built-in contributor to narrowly defined data actions. Quick win you can achieve today. Pick your top 10 enterprise apps with directory. And no owner. Assign owners, remove unnecessary scopes, and replace secrets with certificates. Then switch one high-value pipeline to a user-assigned managed identity with resource-level scope. You will have removed a shadow admin, cut a blast radius in half, and proven to your developers that governance can be faster than drift. Workload identity is production identity. Govern it like it can change your tenant, because it already can. Case study context 4. B2B guest access undermining governance. External users are where your assumptions fail fastest. Guests don't inherit your norms, your device posture, or your escalation culture. Architecturally, they are identities from another tenant that your control plane chooses to trust. That distinction matters because once you invite them, Entra compiles their assertions into your authorization graph exactly like a member, unless you encode the boundary. The pattern is predictable. A vendor is added temporarily for a migration. They can't pass your prompts, so someone excludes the guest group from MFA just for a week. The guest is also placed in a nested group tied to a privileged app role to speed up testing. Months pass, the project ends. Nobody runs an access review. The vendor consultant changes jobs, their guest object persists with the same assignments. Your tenant now hosts a privileged identity controlled by another company's lifecycle. Dead signals show up in 3 places. First, hard exclusions. If you see conditional access policies that explicitly exclude guests and external users, you've dissolved your perimeter. Guests become the path of least resistance into sensitive apps because they never meet the compiler's requirements. Second, missing reviews. Access review configurations that target guests but list no reviewers assigned or never complete are governance in name only. Without a human accountability loop, time always wins. Third, nested groups. Guests rarely get direct role assignments. They arrive via a group mapped into an app role or an Azure RBAC assignment. Nesting hides privilege escalation under collaboration. Now the near miss that turns into a headline. A partner system integrator is added as a guest admin during a rollout. To keep velocity, the project team excludes the guest group from phishing-resistant requirements and carves a trusted location for their office IPs. The partner later merges. The engineer's home tenant changes IDP behaviors. Their device compliance posture drifts. Meanwhile, the exclusion persists. An attacker compromises the partner account through a commodity phish. Your logs show a legitimate guest accessing an enterprise app with admin privileges from an allowed IP. There is no MFA challenge because you excluded it. There is no device check because you trusted a CIDR. There is no review because the project closed. That is not a bypass. That is your policy. Root cause, treating external collaboration as a people problem instead of a control plane problem. You invited identities you don't govern, then applied weaker policies to avoid friction. You delegated privilege by group nesting, a mechanism that composes invisibly. You never enforced lifecycle. The execution engine enforced what remained. Before we continue, you need to understand cross-tenant trust. Inbound trust controls which signals you accept from an external tenant. Has the user done MFA there? Are they on a compliant device there? Are they hybrid joined? If you don't configure inbound trust, your compiler cannot reuse those assurances. It will either prompt again or, if you excluded guests, prompt never. Outbound trust defines what your users carry into others. Both require intent. Neither exists by default in a way that matches your risk. Evidence you can pull without a clicking class. Sign-in logs filtered to user type guest with conditional access not applied due to user excluded or application excluded. If this intersects with high-value apps, you've encoded exception as design. Access review summaries showing privileged groups with guests and completion rates below 100% or reviewers set to auto-apply disabled. And that's persistence by paperwork. Enterprise app role assignments where principals are groups containing guests. Expand the groups. If guests resolve to privileged paths, you've hidden escalation in membership. Cross-tenant access settings. Inbound trust not configured to accept strong signals or configured broadly without tenant, allow lists. Everyone can bring their MFA is not a policy, it's a wish. Common mistakes to avoid. Blanket guest exclusions from MFA to avoid friction. Friction move to incident response, using group nesting to convey app admin instead of granting time-bound access via entitlement management with expiration. Nesting is durable. Packages can expire. Confusing redemption with governance. A guest clicking an invite proves email control once. It does not prove ongoing legitimacy or need. Assuming they're in our teams equals they are safe. Teams is an app. Authorization spans far beyond chat. The uncomfortable truth. Guests bypass your internal assumptions unless you force convergence. You must either accept external strong signals explicitly via cross-tenant trust or require your own strengths. Anything in between is ambiguity. The compiler will resolve in favor of whatever branch excludes the object. What should you recognize today? Policies excluding guests and external users, or trusted locations that exist solely for vendor IPs. Guest objects with last sign-in older than your review cadence, still holding app roles or group memberships. No entitlement management catalogs for external access. All guest provisioning done ad hoc. No quarterly access reviews scoped to privileged groups that include guests, or reviews that complete with don't know decisions, auto-apply to approve. The fix pattern is simple, not optional. Constrain inbound trust, require phishing-resistant strengths for guests accessing high-value apps, or accept external strengths only from allow-listed tenants. Replace ad hoc nesting with entitlement packages that expire by default. Attach access reviews and deny role elevation by group membership. And turn on reviews with accountable reviewers, not self-review for vendors. External identities are not special users. They are another control plane input. Treat them as such, or they will become your most durable exceptions. External identities. Constrain trust. Enforce lifecycle. Guests don't break your tenant breaks itself by trusting guests without constraints. Architecturally, a guest is just an external principal whose assertions you decide to accept. That means two questions matter more than everything else. What signals will you trust from their home tenant, and how long will that trust persist without human review? If you're a security leader, this is your job. Decide what you will trust, from whom, and for how long. Explicitly, not by accident. Why this matters. External identities bypass your internal assumptions by default. They don't share your device posture, your escalation paths, or your training. If you don't encode boundaries, the authorization compiler will treat them like members on every path you forgot to protect. That distinction matters. So draw the boundary in the only place that works, the control plane. First principle, require strengths or explicitly accept external strengths. If a guest touches anything high value, identity admin, finance apps, policy surfaces, your options are binary. Either require phishing-resistant authentication in your tenant, or configure inbound cross-tenant trust to accept phishing-resistant signals from allow-listed tenants only. Guests do MFA somewhere is not a control. It's ambiguity. Second principle, deny elevation by nesting. Group nesting is durable, opaque, and composes privilege silently. If a guest needs elevated access, package it. Use entitlement management with an access package that includes the app role or group, an expiry, and an access review. Time boxes are blast radius windows. Nesting is persistence disguised as convenience. Third principle, enforce lifecycle. Governance is not an invite email, it's an ownership loop. Assign a business owner for every external access package. Require justification and an expiry at issuance. Attach a quarterly access review with accountable reviewers, and auto-apply results. Don't know should never become approve. If a reviewer can't vouch, access ends. These are not bureaucratic steps, they are entropy breaks. Before we continue, you need to calibrate trust. Inbound cross-tenant settings let you accept 3 external assurances. Has the user completed MFA? Is the device compliant? Is it hybrid joined? None of these are universal. If you accept them broadly, you're outsourcing your perimeter to unknown policies. Accept them from named tenants with which you have contractual assurance, or don't accept them at all. Then require your own strengths. Evidence you can surface quickly without turning this into a clicking class. Sign-in logs for user type equals guest, where conditional access equals not applied due to exclusion. Access review statistics for privileged groups that include guests with completion rates below 100%. Enterprise app role assignments where the principal is a group containing guests. Inbound trust configured to trust all external MFA. Each of those is a path of least resistance. Each is a policy choice. Now, make the compiler do the hard work. Define an authentication context called external privileged. Bind it to a conditional access policy that requires phishing-resistant strengths. Require that context for admin portals, finance systems, and any app that modifies authorization. Link PERM activation for directory roles to the same context. If a guest ever elevates, they meet the same bar as members. Create entitlement catalogs per vendor or program. Package the minimum roles with a default 30-day expiry. Require sponsor approval and business justification. Attach an access review that triggers at 25 days. Auto-apply removal if the review doesn't complete. You are encoding decay into the privilege lifecycle. Deny role elevation by group membership in your process. If a team asks to nest a guest-containing group into an app role, the answer is no. Offer an expiring package instead. Nesting produces invisible escalation. Packages produce predictable expiry. Constrain inbound trust. Maintain and allow a list of partner tenants you will accept strong signals from. For everyone else, require your own strength. If a vendor says their devices are compliant, trust but verify. By not trusting externally unless you've onboarded that tenant explicitly. Common mistakes to avoid. Creating guest exclusion conditional access groups. You've taught the compiler to bypass policy for the identities least likely to meet your assumptions. Assigning guests to tenant-wide roles temporarily. Tenant-wide is never temporary. Any privileged guest path must be time-bound and tied to an access review. Treating Teams membership as governance. Teams is collaboration. Authorization spans Exchange, SharePoint, apps, and Azure. If a guest exists only because they're in a team, they should not inherit anything outside that team's scope. Setting reviews to self-review for vendors. Self-approval is not oversight. Make the sponsor accountable. Proof you can show yourself in a week. Guest sign-ins to high-value apps now show authentication requirement, phishing resistant, or external MFA accepted, trusted tenant. No, not applied. Access reviews for privileged groups that include guests complete at 100% with auto-apply enabled. Stale guests are removed automatically. Entitlement packages exist for the top 3 vendors, each with default expiry and a named sponsor. Cross-tenant inbound trust is set to none by default, with a short allow list populated intentionally. The uncomfortable truth remains: external identities are not special users. They are inputs to your authorization compiler. Constrain what you trust, enforce when it ends. Without that, the most durable exceptions in your tenant will belong to people you don't employ. Define the model. Identity debt and measurement signals. Identity debt is not a vibe. It's an operational state, standing privilege plus ungoverned exceptions plus unowned identities. When those 3 coexist, the authorization compiler emits decisions that diverge from intent, and entropy grows. You don't need a philosophy to see it, just a model and the right signals. Start with the model. Standing privilege is any permission that exists outside the window of work. Tenant-wide roles assigned permanently, service principals with broad scopes that never expire, group memberships that convey app admin until further notice. Ungoverned exceptions are branches in the execution path with no owner and no end. Conditional access exclusions, trusted locations, report-only policies that make you feel good but do nothing, legacy protocol carve-outs that were temporary. Unowned identities are principals, human or workload, without accountable stewards. Owner, none on enterprise apps. Service principals tied to departed developers. Guests without sponsors. Combine any 2, you get risk. Combine all 3, you get debt. Now measure it. If you can't inventory it, you don't control it. If you can't measure it, you can't pay it down. So define a minimal signal set that maps directly to the model and is cheap to collect. If you're a security leader, this is the part you should be asking for in every review. Show me the signals that prove our intent still matches what the compiler actually enforces. Signal 1, exclusions. Inventory conditional access policies for user, group, and application exclusions. The question is simple. Which paths bypass the compiler? Count them, tag owners, stamp expiries. Any exclusion without an owner and a clock is an orphaned branch. Signal 2, legacy authentication. Plot legacy protocol activity over time. You're not proving an attack, you're proving unobservable access. A flat line at 0 means your block legacy policy is complete. Anything above 0 is either drift or an exception. Both are dead. Signal 3, non-expiring secrets and long-lived credentials. Pull application registrations and enterprise apps with password credentials or key credentials that are null or beyond 365 days. Filter for high-risk scopes, directory. And flag those with no owners. That is shadow admin without lifecycle. Signal 4, broad scopes. Enumerate service principals with graph permissions beyond what their workload needs and Azure role assignments at subscription or management group scope. The metric isn't only how many, it's how many with scopes that don't map to a resource you can name. Signal 5, guest privilege. List guest users in privileged groups or app roles, especially those introduced via nested groups. Cross-reference with access review completion. If guests hold durable privilege and reviews don't complete with auto-apply, you've encoded persistence. Signal 6, synchronized admins. Join directory role assignments against on-prem sync enabled. Any tenant-wide role bound to a synced identity is coupling across planes. That's not a red dot, that's a design decision to unwind. Translate those signals into a measurement set you can run every week without a ceremony. Exception inventory, count of CA exclusions with owner and expiry coverage. Secure score identity deltas, not as a single number but as change over time for identity controls you care about, legacy auth disabled, MFA coverage, privileged identity protections, policy count versus coverage. Number of CA policies and percentage of sign-ins evaluating at least one baseline policy. Access review completion rates for privileged groups and guest catalogs. These are not vanity metrics. They tell you where governance exists in practice. Minimal telemetry required to support this. 3 places. Sign-in logs filtered to conditional access not applied with reasons user excluded or application excluded, and client app legacy authentication. Enterprise app owner coverage from graph, giving you a consistent owner count per high-risk principal. Access review outcomes with completion status and auto-apply flags. That's it, you can add more later. The goal is directional truth with low overhead. You'll notice what's missing. Screenshots of portals, checklists of toggles, and weekly hand counting. Those are how you drift. The compiler does not care how you feel about complexity. It cares what you told it yesterday. Your measurement must reflect that. Machine-readable inputs and machine-observable outcomes. Now anchor this to the identity debt accumulation loop, so your team speaks the same language. Intent leads to translation. Translation spawns exceptions. Exceptions orphan when owners leave. Orphans persist and mutate the authorization graph. Your signals map to each step. Secure score and policy coverage show intent drifting at translation. CA exclusions and not applied sign-ins expose exceptions. Owner, none, and long-lived credentials identify orphans. Guest reviews and rotation metrics reveal persistence. You're not auditing feelings, you're tracing state propagation. 2 cautions. First, don't normalize debt into averages, a single service principle with directory. Read right. All and no owner is not balanced by 10 low-risk apps with owners. This is blast radius math, not sentiment analysis. Second, resist score chasing. If a metric can go up while risk stays flat, drop it. Prefer signals that correspond to real blocking behavior or real lifecycle action. The payoff is simple. With 6 signals and 3 reports, you can say something useful at any scale, where the compiler is bypassed, where privilege is permanent, where nobody is accountable. That's the definition of identity debt operationalized. And once it's visible, repayment stops being theater. It becomes work. Ship this week, minimal enforceable baseline. This is the part everyone postpones. Don't. You can ship a minimal enforceable baseline this week that reduces blast radius before it reduces flexibility. It won't fix history. It will stop adding interest. Start with 3 baseline policies the authorization compiler can execute without ambiguity. Policy 1, block legacy authentication. Target all users, all cloud apps, client apps, legacy protocols only, no exclusions. This removes the unobservable path. Your logs go from we think to we blocked. If someone claims a business dependency, they owe you a protocol upgrade plan, not an exception. Policy 2, require MFA for all users, target all users, all cloud apps. Grant, multi-factor authentication. Exclusions, only the 2 emergency accounts with an expiry and an owner. Attach an alert to any sign-in where conditional access equals not applied due to exclusion. If you can't see the break glass path, it doesn't exist. Policy 3, require phishing resistant strengths for privileged roles and critical apps. Target directory roles and named enterprise apps that modify identity, money, or policy. Grant authentication strength, phishing resistant. Optionally require an authentication context that enforces compliant device for PM activation. This collapses prompt bombing and OTP social engineering on the paths that matter. Governance moves next. These are not toggles, they are intent encoded. 2 tested break glass accounts, cloud only, long vaulted passwords, excluded only from MFA, and allow listed by location to a narrow egress you control. Document where they live, who can open the vault, and how long it takes. Validate sign-ins show in logs and that only the baseline block legacy policy evaluates. Put a calendar reminder to test monthly. Break glass isn't a username, it's a practiced pathway. Privilege identity management for every tenant-wide role. Set assignments to eligible, require strong authentication at activation, set durations measured in work, not days, and require justification. If you have P2, link an authentication context so elevation inherits phishing-resistant requirements and device posture. Make the compiler re-evaluate risk at the moment privilege appears. Exclusions with clocks and owners, inventory current conditional access exclusions. For each, add an owner, a business reason, and an expiry within 30 days. Anything without those 3 gets removed. This single step converts orphans into time-boxed debt you can actually pay down. Now, lifecycle for non-humans. Owner required on enterprise apps and app registrations. Hard rule, no owner, no production. Surface a weekly report of owner, none, on principles with directory. Scopes and route it to the identity queue. Replace secrets with certificates where secrets still exist. Target 90-day lifetimes or automated rotation. For pipelines outside Azure, move to federated credentials. For those inside, switch to user-assigned managed identities scoped to resources they touch. You're not chasing perfection. You're removing forever secrets and shrinking scope. Guest lifecycle in one move. Entitlement management for external access. Create a catalog per top vendor. Package only the roles they need. Attach a 30-day expiry. Require a sponsor. And attach an access review at day 25 with auto-apply. Block group nesting as an elevation mechanism in your process. If someone asks to nest, the answer is use the package. Time boxes are entropy breaks. Nesting is persistence. Scope guardrails for hybrid. Zero synchronized global administrators. Cloud-only admin accounts for tenant-wide roles. Admin units that reflect real seams, region, subsidiary function with role assignments inside them. That lets you retain regional delegation without spraying tenant scope. It also decouples on-prem health from cloud admin paths. Evidence beats belief. Prove the baseline with 4 checks you can run in an hour. Sign-in logs where client app equals legacy authentication and conditional access equals blocked. Trend should converge to 0 attempts or 100% blocked. Any not applied means drift. Conditional access not applied to privileged roles. The target is empty. If you see exclusions firing for admins, you have blind paths. Authentication methods for members of privileged roles. The column you care about reads phishing resistant registered. If it's empty, your admin label equals risk. Enterprise apps with directory and owners count equals 0. That queue is your shadow admin list. Work at this sprint, you'll get pushback. We'll break operations. Standing privilege is the break. PM is the safety. Too many prompts, strengths for admins, risk-based prompts for users, block legacy and prompt noise drops. We trust our network. The compiler doesn't. It trusts signals. Guests slow us down. Packages with expiry are faster than incidents. The order matters less than momentum. Ship the 3 policies. Validate break glass. Turn on PIM. Timebox exclusions. Assign owners. Replace 1 secret with a certificate and 1 pipeline with a managed or federated identity. Create 1 external access package with an auto-applied review. Then schedule the rest. This baseline isn't a destination. It's a floor. It reduces blast radius before it reduces flexibility. It trades invisible ambiguity for visible control. And it gives you a control plane that enforces intent, not memory. Evidence without demos, queries, logs, diagrams. We're not doing a clicking class. We're going to show you how the control plane behaves with 3 artifacts you can screenshot, annotate, and repeat. Diagrams, logs, and short queries. No theatrics. Just state and flow. Start with the diagrams you'll reference all year. Diagram 1. Conditional access evaluation flow. At the top, request context. User, role, app, device, location, risk. Branch 1. Exclusion strip objects from scope before evaluation. Branch 2, blocks short circuit. Branch 3, grant controls combined with an insider policy. Effective requirements are the union across applicable policies. Outcome decision plus the telemetry you expect if the policy actually applied. Label the left edge, entropy generators, and pin exclusions there. It teaches why not applied equals blind path. Diagram 2, identity debt accumulation loop. Intent, translation, exception, orphan, persistence. Wrap a circle arrow around it and note the compiler sits across every hop. You will point to this when someone argues their 1 temporary bypass can't hurt. Now the logs, because screenshots of state beat opinions. Log 1, sign-ins filtered to privileged roles where conditional access result equals not applied. Add columns for result detail and authentication requirement. If the detail says user excluded or application excluded, that's unaudited code running. If authentication requirement is blank, the compiler required nothing. 1 screenshot, 1 truth. Log 2, legacy authentication. Filter sign-ins where client app equals legacy authentication. Trend the count by day. Overlay conditional access result, A blocked. The target is 100% blocked or 0 volume. Anything else is drift hiding in a protocol, not a network rule. Log 3, guest access to high-value apps. Filter on user type equals guest and app equals the admin portals or finance systems. Add authentication requirement and conditional access result. If you see not applied or MFA accepted external without inbound trust allow listing, you've encoded ambiguity. Snap the trend before and after you constrain trust. Queries next. Keep them short, readable, and survivable in a change window. Graph query for shadow admins without a steward. Enterprise apps where app role assignments match directory. And owners count equals 0. That list is your emergency queue. Work it first. Graph query for forever secrets, application registrations where password credentials and date time is null or greater than 365 days. Sort by high-risk scopes, present on related service principles. Tag an owner, set a rotation date, replace secrets with certificates or federation. Graph query for scope bloat, service principles with role assignments at Wunsch, tenant or subscription scope. Join to their display names and tags. If you can't map to a living workload, you found consolidated blast radius. KQL excerpts you can paste into a workbook. KQL, privileged sign-ins with blind paths, sign-in logs, where is notempty, tenant ID, where toString, identity info. Roles has any, global administrator, privileged role administrator, application administrator. Summarize attempts and count as here's blind paths, count if, result type, equals and conditional access, status equals not applied. By BN, time generated, 1D, KQL, legacy auth blocked versus not applied. Sign-in logs, where client app used, legacy authentication. Summarize blocked. Countif, conditional access status, XOs, failure. Not applied. Countif, conditional access status, XOs, not applied. By BN time generated, 1D, KQL, guests hitting sensitive apps. Sign-in logs, where user type XOs guest and app display. Name in. Microsoft Entra Admin Center, Azure Portal, SAP S4 HANA. Summarize MFA REQ, countif, authentication requirement, has phishing resistant. Not applied. Countif, conditional access status equal not applied. By bien time gene rated 1D, add 1 workbook chart per query. Left axis is count, color the not applied series in red. Architects learn fast when red fades over time. For workload identities, you won't see prompts, you'll see changes. KQL, service principal consent and app role activity, audit logs, where AAD operation type in, consent to application. Add app role assignment to service principal. Extend actor equals toString initiated by app.servicePrincipal display name, my summarize events count by bin time generated 1D actor. If that chart spikes outside change windows, you're watching drift. Finally, create a one-page evidence board. Top row, the 2 diagrams. Middle row, 4 tiles, privilege not applied, legacy blocked, guest strengths, shadow admins without owners. Bottom row, owner none count, exclusions with owner and expiry coverage. Secrets 365 days count, update weekly. No meetings, no narration. The board tells you if entropy is growing or shrinking. This is the point. You don't need a lab. You need artifacted truth, diagrams to align mental models, logs to show flow under the compiler, queries to find the places policy never ran. That's evidence without demos. That's how you govern at scale. Paying down identity debt, a 90-day remediation cadence. This is not a heroic weekend. It's a boring, disciplined loop that shrinks blast radius on a schedule. 90 days is enough to move the compiler from ambiguity to intent without paralyzing operations. 3 phases. Clear artifacts. No ceremonies. Days 30. Inventory, isolate, and stop the bleeding. You're not fixing history, you're halting interest. Start with exclusions. Pull every conditional access policy and export the exclusions. For each, stamp an owner, a reason, and an expiry. Anything without all 3 gets removed or sunset in 7 days. Create a weekly alert on sign-ins where conditional access not applied due to exclusion scoped to privileged roles. If a break glass path is excluded, add visibility now. Allow list the egress, exclude only from MFA, and validate sign-ins show in logs. If you can't see it, it's not a control. Disable legacy protocols everywhere. Don't negotiate with IMAP, POP, or basic auth. Expect noise. The noise is deferred work returning to sender. Log trend should converge to 0 attempts or 100% blocked. Stage PM for tenant-wide roles. Make assignments eligible, require strong auth at activation, set durations you can defend, and require justification. If you have authentication contexts, tie elevation to a phishing-resistant strength. The goal is the first elevation that re-evaluates risk. Inventory, non-human authority, query enterprise apps with directory. And no owners? Application registrations with secrets older than 365 days or null end dates, and service principals holding subscription or tenant scope roles. That list is your shadow admin queue. Don't debate names. Tag owners and publish the queue. Finally, test break glass, 2 cloud-only accounts, long vaulted passwords, MFA excluded, location allow listed. Execute a sign-in and capture the evidence, visible in logs, blocked by legacy policy, not blocked by strengths. Put the test on a calendar. Days 3160. Replace the worst paths and collapse scope. And this is where velocity returns. Replace secrets with rotation. For the top 10 application registrations with forever secrets, switch to certificates with 90-day validity or federated credentials. Store private keys in Key Vault and rehearse rotation. If you can't rotate on demand, you don't own the principle. Move pipelines. If the automation runs in Azure, convert to user-assigned managed identity scope to the smallest resource they touch. If it runs outside Azure, federate identity HG, GitHub or IDC to remove stored credentials. This removes entire classes of failure. Screenshots of environment variables, exported configs, copied secrets. Trim conditional access to a baseline. Reduce to 3 policies. Block legacy, MFA for all, phishing-resistant strengths for admins, and critical apps. Delete policies that overlap or weaken the bar. Any remaining exclusion needs an owner and a clock. Move trusted locations logic into authentication contexts bound to device compliance. Stop trusting CIDRs as identity. Turn on access reviews. Target privileged groups and guest catalogs. Assign accountable reviewers, not self-review. Enable auto-apply and set a cadence that aligns with risk. Reviews that don't complete are not neutral, they're persistence. Localize power. Create administrative units that reflect real seams and delegate roles inside them. Remove synchronized tenant-wide roles. Ensure every principal with R's scope is cloud-only and PIM eligible. You're converting OU nostalgia into scoped control. Days 6190. Right size, enforce strengths, and institutionalize decay. This locks in the gains. Right size graph permissions. Replace directory bumped read-write. All with the minimum app roles required by each workload, or move to your own APIs with app roles. For Azure RBAC, drop scope from subscription to resource group or resource. and from contributor to precise data actions. This is not paperwork, it's the only guardrail machines will see. Enforce phishing resistant for the paths that matter. Validate that every member of a privileged role has a registered phishing resistant method, where they don't pause elevation eligibility until they do. For PIM, require the same strength via authentication context. Elevation should not lower the bar. Institutionalize expiry. Entitlement packages for external access get 30-day defaults, a sponsor, and reviews at day 25 with auto-apply. Conditional access exclusions expire by default. Application credentials expire by policy. Owner, none, triggers a ticket, not a shrug. Measure weekly. 3 charts, privileged sign-ins with not applied, legacy auth blocked versus not applied, and guests hitting sensitive apps with authentication requirement. Add 2 counts, owner, none for high-risk enterprise apps, and secrets 365 days. If red doesn't fade, you didn't change state, you changed slogans. Close with the after-action loop. For every incident or near miss, map it onto the identity debt accumulation loop. Where did intent fail? Translation, exception, orphan, persistence. Add a guardrail at birth. Consent workflow requires an owner. App creation requires tags. Break glass tests are monthly. Exclusions auto-expire. You are encoding decay breaks. What about objections? Will break operations. Standing privilege is the break. PIM is the safety. Too many prompts. Strengths for admins, risk-based prompts for users. Vendors can't meet your bar. Allow list trusted tenants and accept their strengths, or require yours. Anything in between is ambiguity. 90 days won't make you perfect. It will make ambiguity expensive. That's the point. The compiler will enforce what remains, make sure what remains reflects intent, then repeat the loop. Entropy never stops, neither should you. Objections, rebuttals, and system behavior. Will break operations. The system already did. Standing privilege is the operational break. You just don't notice until an incident forces a rollback. Privileged identity management is the safety harness that converts always-on risk into on-when-needed control. Architects don't argue with gravity. They install guardrails. Eligibility with justifications and short activation windows is that guardrail. The compiler re-evaluates risk at elevation. That's not friction, that's intent enforced at the moment damage becomes possible. Too many prompts. Prompts are a symptom of weak assurance, not a design goal. When you require phishing-resistant strengths for admins and high-value apps, the prompts collapse. No OTPs to retype, no push fatigue, no SMS fallbacks. A device-bound assertion turns naggy MFA into a zero-interaction key assertion. For everyone else, risk-based prompts plus blocked legacy auth reduce noise at the source. You don't win by tuning prompts, you win by removing the failure class that created them. We trust our network. The compiler doesn't. It sees signals, device posture, role, app sensitivity, risk. A CIDR is not a signal, it's a story. Trusted locations teach the authorization compiler to treat an IP range as identity. That's how you smuggle unmanaged browsers and proxied sessions into privileged paths. Replace location bypasses with authentication contexts bound to compliant devices. You are moving trust from a root to an attested state. That distinction matters. Guests slow us down. Incidents slow you down more. Entitlement packages with default expiry and auto-applied access reviews ship faster than ad hoc nesting because they encode the exit on issue. No retro hunts, no who approved this archaeology. A 30-day window with a sponsor you can name beats a nested group that outlives the project and the vendor. External collaboration is a control plane choice. Encode it once, reuse it forever. Vendors can't meet phishing resistant, some can, some can't. The system already supports inbound trust. Allow list tenants whose posture you contractually trust and accept their strong signals. For everyone else, require your strength at your boundary. You're not outlawing collaboration, you're removing ambiguity the compiler can't resolve safely. Absent explicit trust, prompts are not friction, they're your last defense. Our admins need constant access. They need constant ability to obtain access, not standing privilege. The difference is blast radius. With PM, an alertable, auditable elevation stands in for a 24/7 key. Pair it with short activation and authentication context. You didn't slow an admin, you published a state change. Operations learns to plan work in Windows. Incidents inherit accountability by design. This breaks automation. Workloads do not evaluate conditional access. You break automation when you mislabel human accounts as service. Managed identities, certificates, and federated credentials give machines the tokens they need without prompting. Scope is where you control them. If a pipeline fails after you remove directory, read, write, or you didn't break automation, you revealed a design omission, an overbroad grant that never matched the operation. Fix scope, automation returns. Our executives will hate this. Executives hate headlines more. Give them 2 things: strengths where privilege exists and fewer prompts where it doesn't. For day-to-day usage, prompt frequency drops when legacy auth is blocked and risk-based CA is clean. For privileged access, the requirement is non-negotiable. A compromised executive token is a governance event. The compiler can't distinguish CEO from attacker using CEO. Strengths do. This seems complex. The current state is complex. Overlapping policies, phantom exclusions, orphaned secrets, guests nested into admin roles. The baseline is simpler by construction. 3 policies, PM for privilege, expiry by default, owners on principles. Fewer branches to debug at 2 a.m., less surface to explain in an audit. Complexity is already here. You're deciding who owns it, the system deterministically or humans improvisationally. We'll handle this with monitoring. Monitoring sees what the compiler executed. It does not see what it excluded. Conditional access not applied is a blind path. No detection logic can infer a control that never ran. Prevention isn't fashionable, it's physics. Reduce unobservable flows, then monitor the rest. Alerts mean something when the policy graph is small and intentional. This will take too long. Nonsense. The system rewards order. 3 policies shipped this week. PM can turn on in an afternoon. Owners can be stamped by report. Secrets can be swapped for certificates, 1 pipeline at a time. Entitlement packages can start with 1 vendor. You're not migrating platforms. You're replacing entropy generators with guardrails in place with evidence. If you remember nothing else, the authorization compiler enforces what remains. Objections ask you to preserve ambiguity. System behavior does not negotiate. It compiles inputs into decisions every time at scale. Change the inputs, the outcomes follow. Checklist. What you can validate this week. 3 policies exist, applied and visible. Legacy authentication is blocked tenant-wide with 0 exclusions. Confirmation, sign-in logs show client app equal legacy authentication and conditional access equal blocked with no not applied. MFA for all users is enabled. Exclusions exist only for 2 break glass accounts, each with owner and expiry. Confirmation, conditional access policy. B lists exactly 2 exclusions. Alert wired for any not applied due to exclusion. Phishing-resistant strengths are required for privileged roles and named critical apps. Confirmation, privileged sign-ins show authentication requirement equals phishing-resistant. Break glass is real, tested, and observable. 2 cloud-only accounts, long-vaulted passwords excluded from MFA only, allow listed to a narrow egress. Confirmation, a scheduled monthly sign-in appears in logs, blocked by legacy policy, not blocked by strengths. Evidence archived. Privileged identity management is on, not promised. All tenant-wide roles set to eligible, short activation windows, justification required, and activation bound to an authentication context that enforces phishing-resistant strength. Confirmation, 1 successful activation event captured with risk re-evaluation in audit logs. Conditional access exclusions are governed. Every exclusion in every policy has an owner, a business reason, and an expiry of 30 days. Confirmation, exported policy inventory shows 100% coverage. A weekly task checks expirations and removes or renews with justification. Workload identities have stewards and lifetimes. Enterprise apps with directory. Permissions have named owners. Owner none count is 0 or a known tracked queue. Confirmation, graph report lists owners for high-risk apps. Exceptions carry tickets. Application credentials have sane lifetimes. Secrets, it was 90 days, or certificates with automated rotation. End date time null 365 days count is shrinking. Confirmation, weekly delta report. Scope is right-sized. Service principles with subscription or tenant scope mapped to living workloads. Unnecessary contributor grants are replaced with resource-level, least privilege roles or data actions. Confirmation, role assignment export shows scope moved down and role names tightened. External identities are constrained by design. Inbound cross-tenant trust is none by default with a short allow list. For high-value apps, guests meet phishing-resistant strength or supply trusted external MFA only from named tenants. Confirmation, guest sign-ins to sensitive apps show authentication requirement present. No, not applied. Entitlement packages exist for top vendors with 30-day expiry, sponsor, and access reviews at day 25 with auto-apply. Confirmation, access review completion IRU 100%, stale guests removed. Measurements exist and update weekly. 3 charts, privileged not applied counts, legacy auth blocked versus not applied, guests hitting sensitive apps with authentication requirement present. 2 counters, owner, none, high risk, and secrets, 365 days. Confirmation, a single evidence board shows red fading week over week. 1 migration proof, a pipeline switched to a user-assigned managed identity, scoped to a single resource, and 1 forever secret replaced with a certificate. Confirmation, successful run logs plus retired credential ID. If any item fails, you don't debate intent. You adjust inputs to the authorization compiler. Key takeaway and next move. Identity debt is standing privilege plus ungoverned exceptions plus unowned identities, inputs that the authorization compiler will faithfully turn into probabilistic outcomes. Reduce ambiguity, intent becomes enforceable. Ship the baseline this week: 3 conditional access policies, tested break glass, PIM for privilege, owners and expiries on exclusions, 1 pipeline to managed or federated identity. Subscribe for the deep dive on turning conditional access from execution engine into enforceable policy.